Stockholm and somewhere in Norway. We came together in Helsinki. The guys from the different
Davies as a sponsor. Excellent venue. So who are going to do the introductionary words?
Yeah. Is the microphone there?
It's over here.
Yeah. Is it streaming already?
Yes.
Very nice. 1, 2, 3.
Do you want some slides, sir?
No, let's keep it this way. So, welcome everyone. Welcome to the Reaktor Turku office. I'm Otto, and with me from Reaktor is Jonni.
Hello.
And Andy back there. And many have certainly heard of Reaktor. How many of you have already? Okay, cool. But yeah, so I'll keep it shorter. So we do cool projects. We have satellites. We have challenges, which I recommend for everyone. There's a tracking game currently. And we have cool offices like this around the world in 7 countries. Is it 10 offices currently? Something like that. And 550 members in teams. And we continue growing and recommend everyone take a look on our website if there's something interesting for you as well. Yeah, I think that's good.
Where's the toilets?
Of course, yeah, the hosting things. Okay. There's a lot of pizza. There's vegan pizza, there's gluten-free pizza, and gluten pizza. And beers and alcohol-free drinks. And the closest toilets are in the hallway. And I think I forgot something, but just ask me anything if there's.
There's a fire.
Yeah.
Fire extinguisher.
Yeah, of course. Don't start any fires here, please. Thank you. Thank you for coming.
Should I show the website and stuff? Is it working? What can I say? Let's do this. I think we're gonna do. Yes, so I'm going to start by talking a bit about Cloud Native Nordics, or Kubernetes Turku. We're a meetup group and we're a member of this larger organization called Cloud Native Nordics. And we have our new web page where you can find info about which events are coming up and speakers, and you find slides and whatnot. So definitely check it out. It's cloudnativenordics.com. And while you go to the web page, if you want to join the Slack and talk with us organizers or just with people in the same field in the Nordic countries, you can join the Slack by putting your email here, and then you get a confirmation and then you are in. But yeah, that's the website. The agenda for today looks like this. I'm probably gonna close the door. Yeah, so the agenda for today is we're going to have 3 talks. I will start with a brief introduction to Kubernetes and the objects that you will find there. And after that, we will have Andy presenting Nomad. It's a HashiCorp product that's really cool. And then we will end with Lennart, who will do a talk about RBAC network policies and PodSecurityPolicies. But yeah, let's get going since we're a bit behind schedule. I will be talking about intro to Kubernetes objects. This will be pretty basic for some, but I think it's good to have like a solid base for everyone. Since last meetup, a lot of the attendees were new to Kubernetes, so I think it's good to have one of these like shorter talks on the intro stuff. But yeah, first, who am I? My name is Anton Lindholm. I'm currently at Walkbase. I've been there for 3 years. I do sysadmin stuff, and the last 2 years has been mostly Kubernetes for me. Before that, I grew up on a farm in Karjaa, so I have 18 years of managing cattle, and I'm one of the organizers of this meetup. So yeah, what I'm gonna talk about today, as I said, I'm gonna start with a brief introduction to how Kubernetes works, like what are the moving parts. And For people who have worked a lot with Kubernetes, you will find that I have simplified a lot of things. So it will be like a good Kubernetes 101, but then when you actually start to look into it, you will see that it's a bit more complex. And what I'm going to do is I'm going to start from the inside and then slowly work outwards. So we're going to discuss pods, services, replica sets, and deployments. So yeah, what is Kubernetes? It's a production-grade orchestration system. There has been a few other ones around, like Swarm and D2IQ, what was it, Mesosphere, and some others. But like currently, Kubernetes is definitely the most popular platform. What's the benefits of using Kubernetes? One thing that I think is really good is that it abstracts away all the underlying hardware. You don't care about servers anymore. You just care about your cluster. So you just take your workload, you slap it up there, and it just works. And one other thing it does really well is that it converges actual state versus desired state of the system. And what I mean by that is that you tell Kubernetes that I want 5 instances of my app running all the time, and Kubernetes will actually provide you that. It will check that, okay, now it's only 4 instances, I will fire up a 5th one because he wanted 5 instances. And it's also self-healing. A node goes bad, Kubernetes will respawn it for you and so forth. And this last thing here, same API across bare metal and every cloud provider, I think that's really good as well. Like you're never locked in. You can always move if you don't like your current venue. So yeah, here are some other things Kubernetes provides. It's actually a platform for building platforms. Like you start with Kubernetes and then you can customize it to your liking and provide your product that way. Out of the box, you get blue-green deployments. So you start with version A and then slowly move to version B. And if it fails, you can always roll back to version A and get the old state. Jobs and cron jobs is really huge. It's what Jern uses currently. I think they fire off one Kubernetes command and then they have 40,000 nodes who calculates the Higgs boson, for example. And nowadays you can also run stateful applications like databases, Kafka, whatnot inside Kubernetes. And you get native service discovery, which has been a problem in the past. There has been products like Consul and these other like solutions to get it working, but Kubernetes has this out of the box. And then nowadays you have these custom resource definitions, which makes it really easy to integrate with third-party apps. For example, you can have an operator, and then you can tell Kubernetes that, hey, I want a Postgres instance, and Kubernetes sets it up for you. So yeah, this is the brief overview of the architecture. We have the API server, and that's basically the heart of Kubernetes. We have lots of controllers. We have some kind of like stateful database, and then we have your worker nodes. And I will now briefly talk about all these components, like a quick overview. What do they do? How do they work together? And then after that, we will start with the actual like objects. So yeah, first the API server. It's actually the heart of Kubernetes. It provides you this REST API, and it's like the heart of the control plane. So everything that happens through the API server, and then the state gets stored in the data store, which in most cases is etcd. Everyone who interacts with your cluster go through the API server, and the API server handles both authentication and authorization. Then it also just does some request validation, like checks that you don't do any stupid stuff. It also mutates some things, so you can, you will see it later, actually, the mutation. And then, yeah, some other small things. Basically, this is the brains of the thing. Then we have etcd. This is the most popular like data store for Kubernetes. What it is, it's basically a highly available key value database. There are Kubernetes distributions that use other stuff, like, for example, K3s uses SQLite, I think, but that's like an on-edge thing that isn't, or it scales, but it doesn't scale as much as if you would use etcd. And how etcd works is that it uses this Raft consensus algorithm. So you basically have 3 or 5 or an odd number of nodes, and then then when the state gets written, like a majority of the nodes has to agree on the state.
Is there any version in which they would use like something like Redis or something?
You could probably hack Redis into there, but like why would you when there is etcd?
Yeah. It's probably the high availability story that's better with etcd.
Yeah. 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 Then we have the kube controller manager. There are actually like a bunch of controllers that run inside Kubernetes, but this thing controls the controllers. And what a controller is, it's basically a while loop that checks with the API server that what should the state be, and if the state differs from the desired state, then the controller will do the small thing that fixes the state. So, for example, a pod controller would check that is there a pod like this? If not, I will create the pod, and then it will get scheduled to a node. Yeah. I think that's that. Yes, then we have the scheduler. What the scheduler does is that it checks that are there any new pods that haven't been assigned to a worker yet, and if there are those, it will actually assign it to a worker based on what kind of hardware, like CPU, memory, the pod needs. Then you can check, like if you have 3 Postgres pods, you probably have affinity rules that tells Kubernetes that these 3 Postgres pods should not be running on the same node, because then if the node goes down, your whole cluster goes down. So what the scheduler does is that it uses bin packing and some smarts to actually distribute the workload over the cluster. And then we have the kubelet. This is like the node daemon thingy agent, which runs. You run the kubelet on every node in your cluster, and for the control plane for the master nodes, it gets its configuration from the node itself. Like you have static JSON there that tells the kubelet how to act. And then for the worker node, what the worker nodes does, what the kubelets on the worker nodes do is that they query the API server for information, and then the API server tells the workers what they should do. Okay, so let's look at some objects. We're going to start with the pods. This is basically the smallest deployable unit. A pod is one or several containers that is grouped together, and they actually share like the same local host, so they can talk directly to each other. And this is the spec of the pod. If you create a pod, this is what you do. So you start out with giving the pod a name. In this case, we have named it Nginx. Then you give it a namespace, like inside which namespace should this pod work. So you can have like the same spec with different namespaces, and it will actually create 2 pods. Then a really important thing inside Kubernetes is labels. You basically label everything, and you will see later how labels is used. But for example, here we have this is a pretty common label. There you can put app, and then you put the name of the app. But other good labels are like production. You can put production. You can put version there, like version 1, version 2, and so forth. And you can do a lot with labels, so you should use them. Then inside the spec, you can you tell them which container should we use. This is a really short spec, so other things you should also put here is like what kind of resources does this pod need, for example, and these kind of things. And yeah, if you want to see what you can like specify for an object, what you can do is you can run this kubectl explain command, and then you do like kubectl explain pod, and it will actually give you the full pod spec in the terminal. Yes, and then yeah, one thing I forgot to mention about pods is like in the beginning you probably create 1 or 2 pods, but in the long run you almost never create these yourself. You create some other object that creates the pods for you. And one of those objects is a deployment. And as you can see, this is like this spec here. It's a bit bigger, and what the deployment actually does is that it creates pods for you, and then it handles the upgrades and the rollbacks of your pods. And down here you can actually see this spec here is actually the same spec as for the pod. So what this spec here is actually the pod spec, and it tells the deployment what kind of pods you want, and then like metadata labels and so forth. Then, and this is a cool thing here. You have replicas. You can tell Kubernetes through these replicas here how many replicas you want. So let's say in this case we have 3 replicas. But then if you want more replicas, you just edit the deployment, and the deployment will spawn more or less pods for you, depending on what you want. And what deployments give you is that you can attach controllers to the deployment that will actually scale your workload based on the load. So you can have like horizontal scalers that will just increase the amount of instances you run based on the load, or you can do vertical scaling, so you give the pods more resources based on the load. But that's more advanced stuff, so I'm not gonna talk that much about it in this presentation. Oh, and yeah, the one thing I forgot to mention about the pods is that you need to specify which ports they should listen to, which port should be like exposed from the deployment. And then when you have a deployment, you only have like the first part. You don't have the pipeline outward, so to speak. There is no easy way to find your workload if you just have a deployment. And to actually expose your thing, you use something called services. And what services is basically DNS, but inside Kubernetes. This is the service discovery thing I mentioned earlier. Services are namespaced, and you put the service in the same namespace where you have your workload. And how services work is that they use the labels that we had earlier, and the labels if you want to map your service to certain pods, you just put the labels down here in the selector field. So now this service will map to every pod that has the label app nginx. I could also have like a service that's named nginx production, and then I would use selectors app nginx, and then here under I would just put production equals true or just production, and then that service would only map or resolve to pods that are labeled both nginx and production. This thing here would resolve to all pods that are labeled app nginx, which means that it would also map to your production pods. And when you have a service, it gets registered to the kubedns, and then you can, like from inside the cluster, you can resolve one of the pods. Like you usually have like 5 or 10 instances. So you can do an NS lookup to this address here. Like you put the service name, then the namespace, and then .svc.cluster.local. In this case, it will be nginx default svc cluster.local. And when you resolve that address, you will get like an IP, and that IP will point to every pod that this service like maps to.
So that is automatically load balance between them?
Yes, and you can, I think you can even specify which algorithm. But I think it's round robin from the start. Yeah. One thing you can do is, like this is now type cluster IP, and when it gets provisioned, it will actually get like in the spec you will see the IP of the thing, and if you remove that IP there or leave it blank, then it will become a headless service. And then if you do an NS lookup on the service, it will actually give you each and every instance of the pods. It's used, for example, if you run Kafka or RabbitMQ or one of these message queues, they usually use it, and then they load balance it, or they load balance and route their traffic themselves. So it's good for like legacy applications and such. I think most Postgres operators also use those kind of services. Yes, and I actually did the smart thing this time and recorded a short demo clip. Let's see. What I will do in this demo is I will actually deploy the YAML that we actually saw just a few minutes ago, so you can see a bit how it works. And you will see I will use kubectl and like apply. So it's some really basic stuff. Oh yeah, Mac OS, everyone knows this. We need to do it like this then. And for some reason ASCII Cinema doesn't work. please. Okay, so here we have the deployment and the service. And as you can see, it's identical to the thing you just saw in the slides. Oh yeah, pause maybe. Okay, I can't pause, but I did a load balancer thing here instead. So this will actually, you will get the IP inside the cluster, and then you will also get an external IP, which is 10.107.100.12 in this case. And then I apply both the service and the deployment. And here we can see that we have our service. It has this. This is the internal IP, and then that to the right there is the external IP. And then we can check the deployments. And we see that we have one deployment called Nginx with 3 out of 3 ready pods. And there we can see the pods.
And for the external IP, you could probably use like an external load balancer there also.
No, you have to, no, or yes, if you are on AWS, then you get like one of these ELB things, or on Google Cloud you get one thing. But like for us, for example, we use those IPs, and then we have like an AJ proxy on the edge that maps to them. Yeah, and here you can see here you can see the mutations. Like even though the spec I applied was way smaller, Kubernetes actually adds all these like default values for the thing. And yeah, that was the thing. And then if the VPN is still up, we can see that I actually exposed Nginx on the external network. This is like the default Nginx page. Okay, and then next steps. The thing is that these like load balancer IPs are pretty expensive. So what one usually does is that you deploy Nginx or some other ingress controller on like as a service inside the cluster, and then you assign that thing and a load balancer IP, and then what you can do through ingress is that you can actually route services inside Kubernetes to an external domain, and you add SSL and so forth. And it's like the basic way to expose stuff. Then if you want to get more advanced, you can use service meshes and the capabilities they provide. But like start out with an ingress. Then I think the next step from there should be like automate all the things, because writing kubectl in the terminal, it's not as efficient, and then it's hard to like to know what was done in the past and what steps have I taken from there. So either put up some CI/CD system or use GitOps or some other technique. There are lots of guides on how to do that. Then at some point you get into role-based access control and PodSecurityPolicies and so forth. But before that, you should have the automation steps set up. And yeah, Lennart will talk about some of the more advanced stuff down the line. And yeah, if you want to learn more or like want to try out Kubernetes, there is this really cool website called Katakoda. I made a bit.ly link, but what you can do is you just write Katakoda into Google, and you get to this web page where you can basically you get a bunch of courses, and then you press one of the courses and it spawns you a one-node Kubernetes cluster that you can like just try out stuff. And they have like step-by-steps, like do this, do that, do this, and it's like an interactive tutorial to Kubernetes. Then I think the official Kubernetes docs are really good, like well written, and I think that's the thing you are allowed to use when you do the exams as well. So yeah, familiarize yourself with those and the change logs, because Kubernetes is a rapidly moving project, so it's good to read the change logs as well. And then when I started out, I bought this book, Kubernetes Up and Running. I bought the first edition, but there is a new edition that has come out. It's about 50 euros, I think I paid back in the day. I'm not sure what the price is now, but I found this cool place. It's actually, I think it's Azure who gives this book out for free if you sell them your soul through this form. You fill in like name and company and so forth, and then you actually get the PDF version of the book. So I highly recommend that.
Can you unsubscribe to the newsletters after that?
You can probably. You are European, so GDPR them. Yeah, but it's actually I'm not sure how many examples of this book they are giving out, but at least I got one yesterday when I tried out. So check out bit.ly/coolkates book, and then you get the book for free. Yes, thank you for your time. Any questions about this or about Kubernetes in general? Or? Yeah. Yes, thank you. Yeah, like 5-minute break so we can get the next guy hooked up. Andy, are you fine?
Yeah, let's put the laptop up on the
Microphone's on, oh god. Now I have to stop swearing. Which is not going to go well, because I don't have entirely positive views of Kubernetes. So the first thing to point out is the picture on the front of this, no one gets the reference. This is from one person, Crisis. The character is called Nomad. That is the only link there is. And I like cool pictures that are not vaguely related. So I'm going to start with a disclaimer, is that while this is about Nomad and Kubernetes, and why I don't like one of them, it's not specifically Kubernetes that's the problem. Like, I like what it does. I don't necessarily like its implementation. But beyond that, it's actually that I don't like complexity. The non-essential complexity, like you've got non-essential complexity and essential complexity. Essential is the domains, the business problems you're trying to solve, and accidental complexity or non-essential is Webpack, trying to get that running. If ever I want to feel like an idiot, I open up a Webpack config, read it for a bit, and then shut it again. It's not my strong point, so other people do with it. But yeah, I don't like complexity, and Kubernetes feels very, very complex to me, especially if you have to manage any of it, if you're rather than just using it. So as you can see, these two very intelligent, well, one intelligent person and me have tweeted about this. I've said that it's like the systemd of the container world. Systemd does everything in Linux, but it's not great, and lots of people hate it and lots of people love it. Two people like this, and then Cindy Sidharan, who is much more famous and intelligent than me, also posted something about her vague dislike of Kubernetes, and a lot more people agreed, because she's much cooler than I am. But that's enough appealing to power. Let's actually talk about legitimate reasons for disliking it. So this was the only architecture diagram I could find for Kubernetes. I want to steal yours because it's much nicer looking. Actually, I think I will steal yours, with attribution, obviously. The first point on the complexity thing is the number of protocols involved. There's 6, I can count. And the second part of this is not just all of the individual parts, but it points at everything is stored in etcd, which is, I looked up, is apparently how you're supposed to say it, unless I'm saying it wrong anyway. Everything is stored in etcd. But etcd has to be a cluster itself, so you still need to manage and launch an etcd cluster, and I'd rather not. I'd rather do as little work as possible. As a consultant, you should pay me very highly for this. So it means things are easier for you to support when I'm gone. And with all of these different parts that you have to keep moving, there's a lot of places where complexity can sneak in, and when you have an issue with your service that's running in an environment, you now have a lot of different places that could be causing your problems. Based on what I've seen of issues with Kubernetes, it's always DNS. Any problem you've got, it's DNS. That somewhere that is what has killed your application. Nomad, by contrast, the aspect on that's weird, is quite simple. There's one binary. You use that as a CLI application to talk to the Nomad cluster. You use it as the servers to orchestrate the cluster, and you use it as the workers or clients to do the actual work. Deployment-wise, like I said, one on your machine for the CLI, one in an auto-scale group, 3 or 5 of them to manage the cluster, and then thousands of nodes in client mode. The biggest production cluster that they talk about on the website has 10,000 client workers in one cluster. They don't say what platform that's running on, so it's probably an AWS or something. And we'll get into some other applications for large clusters like that in a while. Also, if you want to deploy this yourself, they supply Terraform files for it for both Azure and AWS. And unfortunately, there aren't any like Nomad as a service companies, but I'm vaguely thinking I should probably run one because I talk about it a lot. And if you want to do it locally, you can either just run the Nomad executable yourself. If you call it with the dev parameter, then you get something that runs as both the client and the server at once, and you can just send jobs and use your machine. And they come with Vagrant boxes as well, so you can spin up a cluster on your machine by running 3 separate boxes. And in my longer form version of this talk, that's what I do. I run 3 instances of this in virtual machines and then deploy applications to it and demo it. For time constraints, I don't really have time to do that, but we might be able to get something running afterwards if people are interested. So what they do. So this is the kind of stuff that Kubernetes can do for you. Comes with all of these different features, such as health checks, secret storage. That one really irritates me. I'll get onto that in a bit later. Feature gates, container management, routing, load balancing, storage orchestration, service discovery, auto-scaling, rollouts and rollbacks, and probably a billion other things that I've forgotten. And this is great if you need all of this in your application, but if you don't need any of these parts, tough, they're there, you can't switch them off. Nomad, by contrast, provides these 4 things, which is health checking of your containers, distributing your containers around the cluster, storage to follow those containers, so you can attach a disk storage to a container and say this should follow it, and then rollbacks, so it can do blue-green deployments and canary deployments and things like that for you. But if you want any of the other features that Kubernetes provides, you have to do that yourself. So in this case, it might mean adding Vault for secret storage, or launch darkly for feature gates, service discovery with console, and then load balancing with like Fabio or Traffic or any of the other ones. And this means that you are adding some complexity to it yourself, but you're choosing the complexity to add. Whereas if you decide that you want actual secret storage rather than Kubernetes secret storage, you have to add it to Kubernetes, but you can't switch off the old one. So you just have to kind of hope or write policies, and I think you might be able to do it with the role-based access control to stop people using the other one. But this is all more stuff that I don't want to have to think about. I just want to go, here's some secret storage, and you don't have any choice but to use it because it's the only thing here. That's easier than saying, here's secret storage, and by the way, there's this other one, please don't use it, and we'll try and stop you, but someone will figure out a way around it, because they will. And there is one other minor difference between Kubernetes and Nomad, which I think on its own sells Nomad as being far superior, and that is Nomad has not got any YAML in it, and I hate YAML. I dislike Kubernetes, I hate YAML. Yeah, like no language needs 22 different ways of representing a Boolean. One of which is the word no, and if you've used that as a keyword or a value and you're using country codes and suddenly your JavaScript application thinks Norway is false, that is not quick to debug. So it's not necessarily a problem with Kubernetes. Like if they just used TOML or JSON or HashiCorp configuration language, that would be better. And talking of which, this is HashiCorp configuration language, which is very similar to JSON. It's a JSON superset, I think. And you can use raw JSON as well, but HCL is a bit nicer to read. So the basic structure of deploying with Nomad is that you define a job, you define what data center it needs to run in. Now, if you've only got one cluster, you can just leave it coded as DC1. You do have to specify this though. And then you can specify anywhere between 1 and n groups, and a group can contain many tasks. So in this case, we've got 2 tasks here, which is a Docker container running your application and an Nginx container running Nginx. Usually as a reverse proxy. So you set up your own application, you listen on localhost or non-HTTPS, and then hand off all of the SSL management and everything else to Nginx for you. Now what you wouldn't want to happen is having your 3-node Nomad cluster, and you deploy this, and your reverse proxy is sat in one side of the data center, and your application is on the other side of the data center, and suddenly there's a lot of latency between the two, which wouldn't be great. But because you put them in the same group, if you ask for 4 copies of the group, each pair of tasks gets allocated with its group members, so that you're always guaranteed to have co-location of both the reverse proxy and the application. So this is a bit of setup for the demo that I would do, which is where I start up a RabbitMQ node in Nomad, show it working, and then we move to using a cluster instead. So in this case, we have RabbitMQ, we have a single Docker container, and the only difference here is we have network stanzas. So The network is using port mapping, so rather than having to label the ports by repeatedly specifying the same port number throughout the file, you define on the container level, port map, AMQP is running on 5672, UI is on 15672. And then throughout the rest of the file, and in the actual demo there is more stanzas in there for things like service discovery and load balancing. You can just refer to the ports by the names, and Nomad will figure out that you mean that port number. And in the case of this network resource, because I've only got an empty set of braces here, it'll assign a random port number to expose RabbitMQ on. You don't want to use static port numbers, because if you try and bind two services to, say, port 80, and they end up on the same node, it's not going to work, because you can't bind two things to one port, so you let it pick random ones. The downside to RabbitMQ's clustering is that both the discovery port and the clustering data port has to be the same port throughout the cluster. You can't use random ones. I spent a long time trying to figure this out because I could not get my cluster to work, and eventually someone was like, oh, just specify the same port number everywhere. Right, fine. So that's when you start using the constraints, which are the equivalent of Kubernetes taints. You say, this is a constraint. I'm not allowed to run any of the same workload on the same node, so you can make sure that you don't clash. There's a demo. You shouldn't just pretend you watched it, because I don't have time to do that. So the idea of this demo is that we spawn up a RabbitMQ cluster, we ingest a lot of information, and then we have a number of consumers listening to that RabbitMQ cluster and pulling things off there. But as mentioned already, where do you connect to talk to your RabbitMQ instance? Because I mean, I've got 3 nodes here, but if you've got 50, you have to find the nodes. So RabbitMQ is running on these on random ports, so you need to find the random ports. And if you're running 50 Nomad nodes, you now need to find the right 3 nodes which have RabbitMQ on it. And like in the Kubernetes thing where we had the service for internal DNS, you don't get internal DNS with Nomad. You do use service discovery though. So console is service discovery, and it can do service meshing as well. But in your stanza, again, we just mention that we're using RabbitMQ as a service, and again, port is specified using the label rather than the number. And we have another service reference down here to say that that's the UI. And then your application can just query DNS for, or in this case, query the HTTP API for RabbitMQ. And console supports DNS querying as well, so you can look up like it will be like, for this would be rabbitmq.service.console, and you'd get one or many of the instances back. If you want load balancing, you do need to use a third party. So that's using a Docker container like Traffic or Fabio, which integrate with console and are thus portable across all your clusters. Nothing to stop you using Traffic and console in a Kubernetes cluster. But again, if you decide to use that and you like it, that's nice, but you still have the DNS lookup in Kubernetes. You can't switch it off. So it's more like you can only ever add to Kubernetes, you can't replace parts. Of course, you don't have to use curl. You can also query through, this is the C# client library, doing the same thing, and you get a response back that includes the name of the node, the address, what port it's on, any tags, and other information. And as I said, if you're not using console, that's fine. You don't have to use console. I mean, you should, because it's great, but if you're not using it, that's fine. You just don't get the inbuilt service integration with any other service discovery tools like, I've forgotten the name of it. No, it's completely gone. I think it's, do I have it? Ah, I do have it written down here. Eureka, that was it. Eureka, Zookeeper, and etcd can also do the same thing, but it's up to you to register into the services. You can't like directly integrate Nomad with it. Well, you can if you write a plugin for Nomad, but no one has because everyone uses console. Again, demo of that. This is much more interesting with a demo, but it goes on for a lot longer. And causes me a great deal of stress when my demo stops working because virtualization is fun. Yeah, so this is a snippet that we would have seen in the demo. which is connecting to RabbitMQ. This getRabbit broker uses the service discovery to look up where RabbitMQ is running. And then we connect to it using username and password of guest, because that's secure. Which brings us on to secrets, because you shouldn't be writing guest everywhere or pasting your secrets into source code files or keeping them in repositories, even if you encrypt them in repositories. And really, when it comes to secrets, there's two kinds of secrets we need to consider. You've got static secrets, which are things like third-party API keys, stuff that doesn't change very often. And then you have dynamic secrets, which are what you want to use as much as you can. So when you connect to a database, maybe your credentials are only valid for 20 minutes. So you connect and use those credentials, and when they're about to expire, you get a new set of credentials. This means that if someone breaks onto your system and gets hold of your credentials, they've only got a very small window where those credentials are valid. Now, this is a topic in of itself which I could rant about for hours. I can rant about a lot of things for hours. You have no idea how much self-control this is taking. And on that subject, we'll come to Kubernetes secrets, because they're not secret, they're stored in etcd in base 64, so just make sure no one can access this etcd, because that's secret. You have to trust your administrators, and really, even if I'm the administrator, I don't want to know the secrets. I don't want to have access to them, I don't want to read them, I don't want to know anything about them, because it gives me too much control, and someone could threaten me with a wrench and then I'd give all of the secrets out. XKCD comic is correct. It doesn't matter how strong your encryption is, someone with a wrench will get the key out of you. So from that angle, we use Vault. Vault means that I can set up methods of generating new credentials that I don't know about. Or rather, I don't know what the credentials are, I know how they work. From a deployment perspective, we set up Vault. You configure it with authentication, which are the blue arrows. So when running in a production environment, you probably integrate with AWS IAM or Azure's Active Directory. And developers on their local machine needing credentials can authenticate against Vault with GitHub. We then use either direct integration in your application or with Nomad, which are the yellow lines. So this means that when you deploy an application, it'll ask Vault, I need credentials to connect to a database, and Vault will ask for some credentials. It'll talk to RabbitMQ in this case, generate credentials, store them into Vault, give them to your application, and then when that validity period is ending, it'll delete the credentials from the database, or RabbitMQ in this case, and then signal to your application that it needs to either restart to get more credentials or give it more credentials on the next go round. I have a talk on how to set up Vault, but again, that is much more detailed. This is trying to be a slight overview. So on the complexity side of things, you have two options. You can either do it in your application. Again, this is C#. We just fetch credentials from Vault, which is fine because we now have really fine-grained control of when we fetch credentials. That credentials object comes with an expiry time as well, so you can look at the expiry time and just before it expires, fetch more credentials. And that's great because it gives you really good flexible control, but you have to implement this. And I'd rather not implement this because more code is more code that I have to support, and more support is less time to do other things, like write more code. So the other option is you can do it in Nomad. So in your Nomad file, you can use a console template, which is not technically related to console. It's just a templating system that console has. And in this case, we have integration with Vault, where we say we want the same credential, and we'll write it into a file which is stored in secrets/config.json. This file is locked down so that only your application can read it. And if you want added security, you can use Linux's AppArmor or something similar to lock anything down from reading. Now this way means that we don't have any Vault integration in the application. You can read the JSON file, or you could write these into environment variables that your application reads on startup instead.
How to do that? If you use the config file and your credentials expire, then I guess Nomad refreshes those credentials, but what do you do in the app?
So you have two options. You can let Nomad manage it entirely, and it can either, when credentials expire, it can restart your application, which it'll get new credentials and then start the copy again, or you can configure it to send a SIG any of the Linux signals. So you send it like sig int or sig up or sig user 1, whatever you want to type. You could send sig term if you really wanted to, but yeah, you can just send a signal and say, hey, your credentials have changed. And then in your application, just say, whenever I receive the signal, reread the credentials. So again, it's a marginal amount of complexity to handle the signal, but not much. I mean, come on, even JavaScript can handle signals. Except if you run your application through yarn or npm, in which case it won't pass the signal onto your code. The other slightly related part of this is that Kubernetes only deploys Docker containers. I think. I've not seen anyone doing anything other than Docker with it.
You can use other, like you can use Rocket or...
Ah, okay.
It's actually a quite new thing.
Right. So the difference here is that Nomad has always supported other launchers. So in the demo, which unfortunately you haven't seen, the .NET application I deploy, I don't write it into a container, I just deploy a zip file. So where we've been using tasks with driver of Docker, in this case I'm just using an exec driver. And what Nomad will do is you give it the path to a zip file, down here, and it'll see that it's a zip file, or a 7-zip, or a tar.gz, or anything like that. It'll unzip it into a directory for you, and then run the config command. So in this case, we'll run the .NET application, and we'll pass in the path to our application, which in this case is a .NET consumer DLL. But it doesn't have to be exec. You can use, I've forgotten the word for it, isolated exec, I think it's called. So you can have some level of process isolation, because by doing this, your application does have access to the rest of the system. You lose the Docker isolation. It also supports Java, Rocket, and a couple of other things out of the box. So you don't have to use Docker if you don't want, and it can pull, push, and such from S3 or HTTP APIs of any sort. So it's quite flexible there. Also means that if you're a system that has applications which can't go in a Docker container, say older .NET framework applications, you can still move them into Nomad, because you can just zip them and then run them on a machine. And as a Nomad cluster doesn't have to be just Linux, it supports Mac and Windows as well, and I think BSD. You can just say this one has to run on a Windows machine, and it'll just run on Windows clients. Finally, you don't just have to run normal application jobs. You can do batches and system jobs. Batch jobs are pretty much what you would expect. You queue up 1 million of them, say I want 1 million of these things run with this parameter varying. And that's what the 10,000 cluster is used for, as far as I'm aware of. It's a frame rendering cluster for an animation company. So they just go, right, we've got all these frames, here's the input file names, render these billion frames. And then Nomad runs them to completion, collecting the assets somewhere and hopefully not denial of servicing your storage place. Use S3. And then a system job is something to run on all of your nodes. So you can't say it only runs on these nodes, you just say run this on everything. So if you needed to suddenly push out a certificate or something to all your nodes, create it as a system job, run that, or run once on all your nodes. I think that's all I wanted to cover, and I am just under time as well. So there's some useful links people might like. The top one is this presentation. The second one is the demo that goes with this presentation, which you've all seen and loved. Well, no one hated it. I mean, so. And we've got some interesting things about Nomad and Vault and Console, and the bottom one is this noyaml.com. You should go and have a look at it. It is not me, but it is a very angry person about YAML. Written, ironically, as a YAML document. So yeah, that's got a lot of information about YAML in it. Yeah, I think that was it. So, questions?
Can console handle this kind of build packing that Kubernetes does, where you request this much memory and
Nomad can, yes, and the resource. Yeah, I think I skipped over it. Somewhere in here. Where is my?
Down there as a comment.
There we go.
Ah, there, yeah.
Yeah.
Sure.
So that was another slight difference is CPU and memory specified in megahertz and megabytes rather than 0.1 of a CPU, which I still don't understand. Yeah, so yeah, you can specify that as well. You can also specify disks and whether you want the disk to follow your container. Bear in mind, if you want the disk to follow your container and it gets rescheduled on another node that's on the other side of the data center, it does need to be transferred. So try not to have a crashing application that gets rescheduled a lot.
How does it handle the disk then? What kind of storage drivers does it support?
What do you put in your Linux server?
But does it mean like, let's say rsync or NFS or how?
What it actually uses to do the transfer, I'm not sure. Implementation detail, but it's just an area of disk on the host machine. So if you put a large SAN behind it and said there's a mount point here to use, then it would be using that. But yeah, I don't know what protocol it uses in the background actually. One other thing that I wanted to mention, which is not in this but I read about recently, is the Million Container Challenge, which was written by HashiCorp as a show-off thing, and it was to schedule 1 million containers into a cluster. Ironically, Google paid for this. Google paid the infrastructure for it. And the end of this thing says that they haven't implemented the Kubernetes one themselves because they're not experts in making a Kubernetes cluster, but there's open source code for like what containers are run. And Nomad scheduled 1 million containers in under 2 minutes across whatever cluster they set up. And they have a graph of like how fast it scales and things. And the fact that it handled 3 containers which didn't start, so it actually scaled more. So I'm quite keen to see if someone actually does that in an equivalent cluster size for Kubernetes, because I'd just like to see the comparison. But yes, it can handle large workloads.
How does the licensing work?
It's free if you don't want support.
Yeah, so it's free.
Yeah. It's like all of their products except for Sentinel.
I think Vault also has enterprise license.
Yeah, so all of HashiCorp products are basically free open source enterprise features. Contact them for a quote, which means it's really expensive. Yeah, if you don't, it's a point that I haven't put in this slide set, but it's a point I've made on my blog before of Kubernetes supports, when it breaks, you have a large community and you can pay companies to help you. If Nomad breaks, you don't have much of a community, but the ones actually include most of the Nomad developers. And you can pay HashiCorp to fix it. And they obviously know quite a lot about their own product. So yeah, I mean, in my case, one of the clients I work with, they pay another company to manage their Kubernetes clusters. So I only have to deal with operating the clusters. And yeah, I would not operate a Kubernetes or manage a Kubernetes cluster myself. It's a waste of money. Pay someone else to do it or use a cloud service. It's just not worth your time.
Do they have a community like?
I think so. I've not. They definitely have a Gitter.
Okay, yeah.
I've used the Gitter before. I used the Gitter for that and RabbitMQ when I was first trying to cluster RabbitMQ and throwing things at Windows, because not Windows the operating system. Although, yeah, I was having great difficulties with RabbitMQ because of its weird clustering. Yeah.
But even if you don't want to manage your own setup, what kind of monitoring does this come with?
So it supports, what's the name of it? I think it's got Prometheus metrics out of the box. There's one of the main monitoring tools, it supports that straight out of the box. And then plug in whatever monitoring you want. My monitoring tools of choice is Honeycomb because it does everything. And yeah, pay someone else to manage your monitoring infrastructure. Don't host the monitoring infrastructure yourself, because when your infrastructure breaks and you go, oh, look at my monitor, oh, that's running on the same infrastructure. Now you don't know. Yeah, pay someone else to do it. In fact, that's my advice on everything. If it's not your core competency and not the problem you're trying to solve, pay someone else to do it.
But you're a consultant.
Yes, still pay someone else to do it. I'd much rather offload all your work. This is high quality advice. I should be charging you guys. Yeah.
Have you ever had any like breaks or like blackouts, or has there been any like big failures that you are aware of? Because there is this.
Not directly. We've had things where nodes have died because they ran out of storage space. But again, that was our own fault for not monitoring them properly. I've also seen where someone has tweaked their security groups because some report told them that their Amazon setup wasn't entirely perfect, so they just hit apply on all the recommendations, and then suddenly the nodes couldn't talk to each other. Again, not really Nomad's fault. It would have happened if you were running Kubernetes as well. When I've had problems, they've usually been my fault in applications, because there's only a few moving parts. It's either like an OS issue yourself or an application issue. As long as your clients can talk to the servers, everything else is external from Nomad. You don't have to use console with it, but you can use console to orchestrate the cluster as well. So again, as long as the console ports are open between the right things, it should be fine, unless your DNS servers have fallen over, which I've had happen many times in Kubernetes. Core DNS is the bane of my existence.
Have you tried applying a service mesh on a Nomad cluster?
Only via console connect.
Okay.
So my dislike of dislike of complexity makes me avoid Istio and Envoy and all that. Envoy is something that this has for metrics. There's some Envoy endpoint. I saw it the other day. Maybe that was console. Yeah. I avoid the service meshes, but I've already got console in nearly every production workload that I use. And Console Connect does service meshing, so why would I add something else that does service meshing when I've already got something that does it? Unless the other thing does something super specific I want. So yeah, I try and keep my number of tools down, because the more things I have to support, the more things I have to spend time on, and then I can't actually provide value on other things. So yeah, I like to minimize anything that I don't want to think about, which is everything.
Is there something you would still use Kubernetes for, or are you Nomad all the way?
If it's already there, there's a Twitter account that I quite like, which had a graph of when to use Kubernetes. He had two flowcharts. One was, do I need Kubernetes? No. And the other one was, do I need Kubernetes? I work at Google. No, use Borg. I don't work at Google. You don't have a problem? No. I've also said it in a way where I'd say, if you're Google and have got Google scale problems, you've already got Borg. If you're not Google, you don't have Google scale problems, so no. If you've got a lot of people, lots of teams running on the same infrastructure, maybe then.
Would Nomad be easier to use for something smaller then?
I'd say yes, because there's less operational complexity to it. However, if I was just deploying one or two containers, I'd just use Amazon ECS or one of its container services, Fargate or something. I'd avoid trying to use all of this. I just want to deploy stuff and not think about anything. And if I need to run a cluster myself, or if I've already got a lot of infrastructure, so in one place I worked where we had a data center and we were slowly migrating away from that and moving applications out of a data center and into containers and then into cloud. Nomad made sense there because we could run it, we could install the client on every single existing server we had, then add some more to our cloud infrastructure and slowly taint things and move them across as they got ready to move. I wouldn't have been able to do it with Kubernetes because I don't know how to go about doing that, but also because a lot of those applications were .NET Framework 4.7, which doesn't run on Linux or in containers. And we wanted to containerize things.
So do you think that the reason for the complexity Kubernetes is somehow kind of a design failure in versus the Nomad, or do you think that there's a reason for Kubernetes being complex? Does it do
Yes,
more?
there is a reason for it. It does a lot more. It can do a lot more, and it's super flexible. It can do everything. For a company that's Google's scale, that's what they need, and Kubernetes was built based on what they'd learned building Borg, but they couldn't just open source Borg because it's too reliant on internal stuff. So yes, Kubernetes is complex. The complexity is there for a reason. However, I don't think most people have that need for the complexity. A lot of the people I see using it are just using it because they want to put it on their CV. It's resume-driven development, I think someone put it on Twitter. Which is a legitimate way of using it. I mean, if you want to add it as a skill to your CV, use it in production and get someone else to pay for it. Yes, there are use cases, and its flexibility means it can fit everywhere, but how often do you actually migrate cloud providers? It's like when the hotness of ORMs, and people are like, yes, I use an ORM so I can change SQL providers. No one has changed SQL providers. And when they have, their ORM has not been the thing that allowed them to do that. So maybe you can with Kubernetes, maybe not like bits at a time, but if you just take one Kubernetes infrastructure and reapply, maybe. Not sure. I'd avoid doing that as well, because that sounds like a lot of complexity.
Speaking of CVs, how often has management heard of Nomad?
Never.
Yeah.
That's the problem. But if management is telling you you need to use Kubernetes, you might have some other problems because you've got someone giving you a solution and not asking you someone to fix a problem they've got. So we need to deploy our blog. So we want someone who knows Kubernetes and has 15 years experience using it. I worked with a recruiter once who wanted 7 years of .NET experience, and this was in 2007, and I think .NET had been publicly available since 2004. They didn't find anyone. No idea why. Oh, I think I've been ranting for long enough, so thank you.
Thank you.
have a vague urge to stamp on my feet every time I see them. It's fine. I call myself the N in
Picture's on.
CSS,
Excellent.
so I'm happy.
Okay, yes.
All right, guys. Should we get started again?
It's you versus beer. I think beer's winning.
Oh, crap. So yeah, back to Kubernetes landscape. I'm sorry to say, Andy, but
I'll survive.
you'll survive. Good. We'll talk a bit about the complexities of Kubernetes. The things that you probably not stumble across the first time you do anything in Kubernetes, but if you're a bit paranoid and you sort of wonder, but what if somebody did that? Wouldn't that break things? And then you'll start to look at these things. Role-based access control, network policies, and PodSecurityPolicies. My name is Lennart Jern. I'm from Raasepori, here like 100 and something kilometers from here. Have been living in Umeå Sweden for 3 years, working for Elastisys. So that's what I'm doing now when I'm back here remotely. We are working quite a lot with these security compliance related things. So that's why I chose this topic for my talk. Yeah, the outline looks something like this. I'll start with network policies. I think that's something pretty much everyone can relate to. It's the firewalls of Kubernetes. Then we have RBAC, role-based access control, and PodSecurityPolicies. Those are more maybe, well, at least PodSecurityPolicies are very much Kubernetes native, not something you see anywhere else really. And then we'll finish off with a demo, hopefully of all these things together. I don't have the time, but just stop me if I'm rambling on for too long. First, we have network policies. As I said, it's the firewalls of Kubernetes. I think this was the first question we got pretty much when we started working in these more security situations. But yeah, in this traditional setup, we have all kinds of firewalls. It's for like an external one, it's internally between the servers, and different layers and all. How do we do all that in Kubernetes? What do we need? And the real problem there is that Kubernetes is much more dynamic. You are not supposed to really choose that. Well, we will deploy the front end on these nodes, and then we'll put a firewall in between, and then we'll put the back end here, and then another firewall, and so on. You're not supposed to do that. You're supposed to let Kubernetes scheduler figure out where it's best to put the pod. And how do you do it then? If you have one there, you want the firewall sort of around them, but yeah, gets complicated. And the secret to all of this, to make this work, is labels. You saw the labels on the objects that Anton presented. You use labels for everything. You put labels on your deployments, of course. That propagates down to your pods. You have them on your services. You have them on your namespaces, everywhere. And then you can use that also for your network policies to say that things with these labels should go together, sort of communicate in a unified way. Right, and then the third point there, it depends on support from the network add-on. This is the modularity of Kubernetes. It's very easy to customize. You can switch out parts. And this was something I heard from KubeCon, that they talked about, that security is a big thing, especially sort of the security 101, to do things by default secure and make it easy to understand. This is something that is maybe not so obvious. it depends on what network add-on you have, if the network policies work or not. You can have them in Kubernetes, but they are not enforced unless you have a network plugin that enforces them. Otherwise, they are just there and looks pretty. So, not very nice. You need to be aware of that. That's a bit small, but I hope you can see it. It should hopefully be familiar, these YAML files now. So this is an example just right from the start, what a network policy looks like. It's manifest just like a deployment or a pod or service or something like this. This one allows pods to communicate with namespaces with the label network green. Okay, let me move over here. So the network policy is in namespace blue. I'm using colors here because it's easy to keep them separated and you sort of know what blue and green and so on is. We have a pod selector. This is again labels. You have to label things. We match everything. We don't put any special there. So we match all pods, but we are in namespace blue. So this is in namespace blue. Grab everything in namespace blue. Then what do we want to modify? We want to modify ingress and egress traffic. And then we have the rules for these. So ingress, we want to allow from namespace selector, again, labels. Match labels, network green. So any namespace that has this label will allow traffic into the pods that are selected here. So all pods in the blue namespace. And then egress, we also want to allow our pods here in the blue namespace to communicate with these network green namespaces. Let's see.
What happens?
Yeah.
What happens if you've got a network security policy that conflicts with another one?
They are sort of you add them on top of each other. So you can create first a default deny, then you allow after that, and then if it finds one that allows it, then it's fine. So that's the way they add up. Yeah, the last point there is, well, it doesn't make much sense before we have talked about RBAC, but it's just that this is also something that our customers ask for sometimes, that we want to separate the duties. We have network guys, they should control the network. Okay, then give them access to control these things and give the developers or whatever team it is access to control the pods. Then you can sort of separate these roles and yeah, let people work with what they know and in that way keep things nice and clean. By the way, just ask if there is something you want to know more about that. I'll go quite quickly through the slides and then focus more on the demo to show how they work like for real. So that was the network policy. I move on to role-based access control, RBAC. This is the who can do what in Kubernetes. So you have 4 of these objects, Kubernetes objects, but it's really just 2, and then you sort of split it into cluster-wide scope and namespace scope. So you have cluster roles and just roles. So just roles, those are inside a namespace and just can only change things in the namespace. A cluster role applies to the whole cluster. Both of these tell you what can be done. This is the what in who can do what. So they don't say anything about who. They just sort of list some kind of privilege, some kind of permission. You can maybe create deployments, or you can delete network policies or something like this. Then we have role bindings or cluster role bindings, and the same thing there. Role bindings are in a namespace and can only change things inside. Cluster role bindings can do things across the whole cluster. These take things like users, groups, and service accounts and match them with roles and cluster roles. You can mix things. You can have a cluster role that you use in a role binding. That makes quite a lot of sense. Maybe you have a very common set of permissions that you want to apply in many different namespaces. So you create a cluster role. It's available anywhere. It doesn't say anything about who can use it, just it's available there. Some permissions. Then you create role bindings in some namespaces that bind to this cluster role. That people in this namespace should be able to do that. Something like this. Yeah. The last part here is the really the magic, the secret sauce. I learned this only a couple of months back, I think, because this is not obvious. What if I create a role and role binding that allows a user to create roles and role bindings? Can they then just, bind themselves to cluster admin, do whatever? No, they cannot, unless I explicitly state that they are allowed to do pretty much anything. So just because they can create a role, they won't be able to break out of their own bubble. They will only be able to create new roles up to the kind of privilege level that they have. This is real magic to me. And it's amazing to see. I have tried it. I created a role, allow the user Lennart to create new role bindings. And then I tried to bind myself to cluster admin, and it says something like, no, this is outside of your boundary. You're not allowed to do that. Like, but how do you know?
You can create like a Fox user and promote that to admin and use that user to
No, you cannot really. That's actually a good question, because now I forgot something that I was confused about when I started with this. The users, that's not an object in Kubernetes. So you cannot create users. You can only reference them. Quite strange. But this, an example maybe would be good. You often set up your Kubernetes cluster so that it has some kind of identity backend, like Active Directory or something. That's where the users are. So Kubernetes will know about the users from there. It doesn't like fetch all the list of users and store them anywhere. It doesn't do that. It just checks when you try to log in or do something, it will just check that. Is there a user like this? Is this like a legit request? And okay, it is. Good. And then it will check the roles and role bindings and see if this user is there anywhere. So that's a really good point. I should probably put this in here somewhere.
Is there a good tool to visualize these roles and role bindings and so forth? Because like if you just use kubectl without any plugins, it's quite hard.
Yeah, I haven't really used any extra tools. I know there are. I think there are quite a lot actually. I know there is something like, what is the name? RBAC manager or something like this that also allows you to. It sort of creates an extra abstraction on top of RBAC to allow you to, or it creates dynamically new roles depending on what you tell it to do. I haven't used it, so I don't know the details, but one thing that can get a bit clumsy with cluster roles and role bindings, especially role bindings, is that you have to specify the users, and you may have to create many role bindings because you have many different users, and sort of the intersection between what roles you have and role bindings means that you will have quite a lot of different combinations there, and it can help with that. Yeah, I think we'll take an example here. So I'll move over here again. We have a role here. Yeah, you didn't have an example like this, right? Where you can actually put the manifest, you can put multiple objects in the same file if you separate them with minus, minus, minus. So this is one object, this is another one. This is the role, and this is the role binding. Yeah, roles look something like this. You have rules. These are like the permissions, what someone is allowed to do. You specify them as an API group first. There are a few different ones, sort of, I don't know them from the top of my head, but there are a few different ones. The core one is maybe the strangest because it's just empty. That's the quotes there. Then there is a resource in this API group, deployments, and then the verbs. What are you allowed to do with this resource? There is one thing, one more field here you can have, and that's resource name. You can say that you are only allowed to do things with the deployment that has this exact name. You're not allowed to touch anything else. Then the role binding binds here the user dev to the role deployer, this one. So that's how you connect them together. Any questions on that? Yeah, you can specify cluster role there also. And the cluster role and cluster role binding is exactly the same. You just add cluster in front there and skip the namespace. That's not necessary. Yeah.
Isn't there like a kubectl command? You can do something like kubectl can I?
Yes, I'll have that in the demo.
Nice.
You can. There is good support both for creating these resources using kubectl and also checking the permissions. Well, quite good support at least. But yeah, you can do kube control, create, role, and then do ---- help, and then you get an example. It's something like you tell it the name you want on it. You tell it actually you can skip the API group. It'll know what the API group is when you tell it the resource, and then you can add verbs, just verbs, create, update, patch as a comma separated thing. Then you get that out. And same with role binding. PodSecurityPolicies. I think I should start with probably explaining why we need this, because this is not obvious, I think. Role-based access control is about the users, the service accounts that are sort of talking to the API server. But it doesn't say anything about the things running there, the pods, the containers. And they can do quite a lot. If you don't limit what pods can do, they can theoretically, you can easily just mount the host path root of the node you are running on and just go fiddle around in the file system and see what you can do there. So you can really do anything. So that's not quite okay. We need to stop that. And this is where PodSecurityPolicies comes in. What can pods do? It's related to RBAC very much, since this is also controlled through RBAC. So for a pod to be able to do things, like anything, it will need to be able to use, that's the verb you put in the role, but to use a pod security policy. And that policy will need to state that the pod is allowed to do this and that. Just like with network policies, this is also something, well, it doesn't depend on a plugin, but it is an admission? Yes, it's an admission plugin, right? So you have to enable that in the API server. Without that, and this is the default on almost any cluster you'll come across. If you do one in EKS or GKE, when you start it, you can have pod security policies, but they don't do anything because it's not enabled. Yeah, that kind of sucks, but it's easy to get started, because otherwise the very first thing you'll run into when you enable this is that nothing works, because all containers are trying to run as root, and that's not allowed. And this is true for almost any container you'll find on Docker Hub, for example. The normal Nginx server that Anton had, it tries to run as root. Not allowed. No. I could add something about OpenShift, so we get a bit more. OpenShift is Red Hat's take on Kubernetes, right? It has a bit more of a security focus, I'd say, than Kubernetes plain. If you use that, you will be forced to use, I think they also call it PodSecurityPolicies. I guess they do now, at least, because now it's very much Kubernetes. And there, you always run into this, because it's enabled by default.
It's a bit like SE Linux on Fedora.
Yep. SE Linux can be controlled with PodSecurityPolicies, by the way. Or you can sort of state, I don't know SE Linux too well, but you can say what kind of SE Linux context the pod is allowed to have, or something like this.
Is that annotations, or how do you specify?
Yeah, I think it's annotations. It's the same for UpArmor also. Yeah, exactly. User ID privilege mode. Yeah, we'll look at an example. But just first, the thing about who creates the pods. Anton showed the very first template that was the pod. Then you create the pod if you apply that. So then you will need to be able to use the pod security policy. But normally it's not the user that does that. It's done through a service account and controller. So when you create a deployment, that holds a reference to a service account. That's one of the things that appeared when Anton showed the full thing that was in the cluster. So the API server mutated the very minimal manifest and added all these default things. Among other things, a service account, which is the default one, and there is always one named default in every namespace. So that one will be used if you don't specify anything else. Yeah, you create the deployment. Kubernetes creates a replica set. The replica set is then then from that a pod is created. The important part is down here, highlighted, that pods act through their service account. This is the service account that is specified in the deployment, usually then, and must be able to use a pod security policy that match their configuration. And that configuration can also be mutated by the API server. So the API server will actually try different configurations if you don't specify them sometimes for pod security policies. If you tell it that this container should run as user 1000, then it'll look at that and say, okay, that's fine with the pod security policy. Then you start the container and it realizes, oh, but it will actually try to run as user 0. That's not okay, stop. But if you in the manifest specify user 0, then it will not even try to start the pod, because then it's immediately just not allowed. Yeah, so the service account must be able to use the pod security policy. This is how it looks like. I tried to be funny here with like the pod security policy is named root. You are allowed to, well, use, nah, it doesn't quite work, but the role is sudo, so you are allowed to do sudo. We have role binding sudoer, so that's who is allowed to do sudo. Then you become root and run. Okay, that's why I have the funny names there. Anyway, root, that's the pod security policy. So this is the new part here. It has a lot of different things that you can fill in, like SC Linux, run as any, because we don't care about that. You can run as any group. You are not allowed to do the privileged mode, so the container is not allowed to be privileged on the node, but it is allowed to have the process inside it run as any user or anything. And then we specify also the volumes that are allowed. But the thing here is, in this example, is not privileged, but you're allowed to run as any user. And how you then bind this is you do a role, API group policy in this case, and you're allowed to use a resource pod security policy. And here it's very important to have the resource name, because if you don't just specify that you're allowed to use pod security policies, then you can use any of them. so you want to be specific here. What pod security policy are you allowed to use? A normal setup is that you have one privileged pod security policy for like the system stuff that really needs to mount in things from the host and so on. And then you have one permissive that is bound by cluster role binding to all service accounts anywhere, or any authenticated user in the system is allowed to use that one, because it's very sort of restricted in what the pod can do. So that's what you usually do. And then you really don't want all the pods to be able to use the privileged one. Yeah, so resource name root and verb use. And then we connect them together there. So the sudo role to this service account, the default service account in that namespace. All right. Let's see. Demo time. I have, by the way, what time should I stop?
So you can continue.
I'll just continue. Oh, good. Then we have time.
Work at like 8 tomorrow morning.
I'll quit before that. I have a GitHub repository. This is not quite, I'd say, ready for use by anyone, but it's public. You can go play with it if you want to. I have used it in like a couple of sort of workshops where I drive the agenda, so I can tell people what to do there. If you try to find your way around, you may be confused. What we are going to look at here is the network policies part and RBAC part. I'll start with network policies. Here's a short README of what we want to do. By the way, I should tell you a bit what I have done before this. You see the prereq here is to have a Kubernetes cluster with support for network policies.
Could you maybe zoom in a bit?
Yes, that, let's see where, something like that, maybe more. Yeah, that's better. I have done this. It's actually in the README how to do it with kind. This is Kubernetes in Docker. You see down there how it works. This is one thing I hope they will do better, say, coming year, that PodSecurityPolicies and NetworkPolicies will be easier to use with these things. Because now it's just like with all other clusters, they don't work out of the box. So you have to do your work to sort of enable them. That's in the README in my repository, how to do that. I have done that. I have a single node cluster here. Let's see. I should probably zoom here too. I can do like this and zoom. Something like that. Yes. Yeah, a single kind cluster, single node with network policies and PodSecurityPolicies. These tasks are sort of a way just to familiarize with yourself with Kubernetes. I'll do them as a demonstration now. There are, I mean, in the README here, you just see some tasks to do. Actually, if you check the repository, there are sort of solutions to the tasks here. It doesn't say that it's solutions. It's just if you check these things, they will be solutions to the tasks down there. And basically now for the demonstration, we'll have a look at what's in there and what I have done. I have actually applied some of these things already. The idea here is to create, we have two namespaces, red and blue. We want default deny network policies first, so don't allow any traffic out or in, just deny everything. Then we want to set up rules so that pods in blue can send traffic to the red namespace, and pods in red can receive packets from blue. It's two-way street, right? So we can set up policies in blue to allow blue to send to red, but red doesn't have to accept that. They can have their own network policies. Yeah, you will need to label your namespaces. Optional, limit access to kube system only to core DNS. This is one thing. If you add the default deny, that includes DNS. So it won't work without explicitly allowing it. Then we'll create a deployment in both namespaces and check that you can reach the service in red from the blue one and not the other way. So let's see here. First, if I look at that, this is what I have running in the cluster now. Is that quite visible? Just ignore the kube system part. That's Cilium is the network plugin that enables network policies, and core DNS is core DNS and kube proxy. Well, yeah. So not interesting for this. We have the same thing running in red and blue. There's an Nginx server, which is, by the way, an Nginx that doesn't run as root. And then we have the busybox, which is running as root, but I created that pod specifically, and I'm cluster admin, so I can. The busybox is for trying to connect from the different namespaces to the other one and itself. There is also, yeah, you can see this one down here is the blue busy box and that one is the red one. So if I, let's see here, I need the, I just want the command for there. So if I go down here to the blue one, I don't think I have applied any, no, I don't have any network policies yet there. It's just completely open. I can connect from blue to blue. That is the Welcome to Nginx page, not so nicely in a browser, but you get the gist. This is the red one. I'm checking first that it can connect to itself. Yes, it can. Let's see if it can connect to blue. Yes, it can. This one also to red. Yes, it can. Excellent. Then, Then we'll take a look at the default deny. So, yes. Two manifests, one in blue, one in red. Pod selector is for everything, so we select all pods in those namespaces. We want to affect both ingress and egress, but we don't add any rules, so nothing is allowed. Let's add that then. I don't want to type these in, so I should have it there. So, let's see what happens now. We don't get anywhere. And actually, it fails now already on the DNS lookup, right? Because it cannot check with core DNS where this thing is. So, not very useful. We will need some more rules here.
Would IP also have been blocked?
Sorry?
Would the IP also have been blocked? Like if you straight go for the pod IP?
Yes.
Oh.
Yeah, because it knows about. I mean, the IP of the pod is an endpoint, so it knows in what namespace that is. Yeah, let's see blue egress here. So up until there is the part where we allow traffic to go to red, and then I just add a part to allow traffic to the kubedns pod, or core DNS has this label. So I allow traffic specifically to the namespace with system true. I add that to kube system, and then specifically to only that pod, just to show some more details on what you can do. You don't have to play at the namespace level. You can specifically target a group of pods.
So if I just label all my pods as being a kube system and kube DNS.
Yeah. Now let's see. Let me check if I have added the label already to kube system. I have not, so I'll do that. Kube control label namespace kube system true. Okay, because otherwise it won't work. Now I already applied also the red ingress. This, maybe I shouldn't have done that. Then I cannot show that just egress is not enough to get also in, but no, there will be other things we can look at instead. So this one is pretty much the same. Note that I also have egress here because I want to allow egress to the kube system core DNS, but otherwise it would be enough with just ingress from blue. Now let's see if we can get something here. Yeah, we got something. But this way it should not work. No. And also, we haven't said that blue is allowed to check itself, so that doesn't work either. It can only talk to red. No talking to yourself. So that's that's the network policies. Did I have anything else here? No, that there. Yeah, this is just more words for what I just did. Oh, I should change that. Maybe no. Okay. If there are no questions on network policies, let's move on to role-based access control.
Can you use RBAC to define like what kind of network policies that a user can choose for their deployments?
No, you can. I mean, with RBAC, you can only allow users to modify network policies. So you can have a group of users that are only allowed to create pods in a specific namespace, and then you have another group of users who are allowed to create the network policies there. But you cannot say anything about the content of the network policies. Yeah. So here, the idea here is to do a bit more with this blue and red namespace. We want users blue and red to be able to create, patch, update, delete deployments and services in their respective namespace, but not the other way. So just getting familiar with like the syntax here, how RBAC works and these things. Here are also some hints on how to use kubecontrol create, and then you'll get. I could show that actually. Let me. Sorry. What did I press? What? Why can't I zoom? No, I see. I disabled the command keys. Like this, create role. This is very helpful. You see the examples up here. These are the important things, I think. You can create like this: role, pod reader, verb get, verb list, verb watch, resource pods. Then you can add -o YAML and -- dry run, so it doesn't actually create it. Then you get the YAML, and then you can copy it somewhere else and start modifying it. Very helpful, especially if you are going to do the certified Kubernetes administrator exam. I can tell you that's very much needed there. Yeah, and this was the part Anton asked about, I think, the auth can I. So let's do just this first. Wrong. Come on. So I am cluster admin. I can do pretty much anything. Yes. You see down there, just yes. I can actually do this even. Can I list? Then I get the list of what I can do, and it's pretty much everything there. Star.star for verb star. So yeah, this list of things this is things that I think anyone authenticated in the system can do. This self-subject access review is exactly what I'm doing now. I'm checking if I'm allowed to do things. Anyone is allowed to check that. And you can sort of get the health and version and things. I can also impersonate users. So I can check as red. What can I do? Not so much. This is just the same list I had up there, but no star up on top there. And then I can check specifically, like the first thing there. Can I create deploy? So I could write deployment here. Then it's maybe easier to understand. I can check as red. Can red create the deployment? No. That's not allowed. But we'll change that, although not in that namespace. Let's start with blue here. I want a role API group empty for services API. Oh, I think I had an error in the slides probably. I think I had this API group, but I had deployments. Anyway, I want them to be able to create, patch, update, delete. So this is just the role. Then I have the role binding, which binds it. So user blue to the blue role I had up there. Not really anything special, just namespaced access to those. So I will, there are identical ones for red, just switch out blue for red and you have the same. So now, auth can I create deployment as red? This should still be no, because I'm in the default namespace. No. But I can add, well, it doesn't matter where I add it, I think, and red. Can I do it in red? Yes, I can. Can I do it in blue? No. So it seems to be working. Let's check blue. Yeah, blue can deploy in blue. Not in red, I hope. No. Just straightforward. I hope I'm not boring you. And here are all the permissions. You can check them all in one go. I think we checked them all. Yes, we did. Then no point in doing this. That we can also, let's do the list instead. Can I list as blue in red? That should not be like anything special, but blue in blue should have something on top. Yes. Here you see services and deployments. I can create, patch, update, delete. There is a plugin, I think, for kube control also that lets you ask who can instead. So you get a list of users who can do something. In this way you just get what can this user do.
Does that need a certain level of cluster access to get the list of users?
Probably. Not sure.
Clusters I use, I can only look at things below the node level. I can't see node or cluster info. And quite often I'd like to be able to interrogate who can do certain actions so I can find the right service account. But I guess this wouldn't run.
I think this is, by the way, probably a good place to mention that normally I don't think you would like create your roles and role bindings like this from complete scratch. There are some default ones. Let me show you that. Kubernetes RBAC default roles. And they are thought through. There are like good abstractions there. You have these, for example, admin, edit, and view, and now this is way too small. Whoa. There, maybe. That page didn't work very... Hey.
Someone said about docs.
Cluster admin is like the root in the whole thing. That's why I'm allowed to do anything. But this, for example, this admin is a pretty good level if you want to give someone permission to do things inside the namespace. They are still locked in that namespace, but they can do pretty much what they want there. They won't be able to create cluster roles or things like on the cluster scope, but they can do things in there. they won't be able to touch your pod security policies, and they can touch network policies inside their namespace. Yeah. Let's go back to this for a second. So now, didn't I have the... Yes, because the second part here of this is that, or task number 4, is to use pod security policies. So create a role-on-role binding that allows the default service account in the red namespace to use the permissive pod security policy. Now I have already created this permissive pod security policy, so this actually exists in the cluster. Otherwise you can just do the exercise and see, like without actually checking for real if there is such a policy. Did I have that here? Yes, it's actually the example from the slides. So you see them sudo PSP role and sudo role binding. So I'll just apply those. And then we should be able to do some interesting stuff, like deploying the Nginx that runs as root. Did I have that here also? Yes. Oh, let's first look at what I'm currently running. That's in here. So this is what I'm currently running. Nginx Inc. Nginx unprivileged. And it runs on port 8080 instead of 80. That's the only difference really. But it doesn't run as root. So that's excellent. But now we can try to change this. If I go back here, we have a demo non-root deploy and demo root deploy. So this one is, I think, the exact same. Yes, Nginx unprivileged. But the other one, root, this one runs the image as root, the normal Nginx image. So let's try to deploy these in, let's do it in both namespaces and see what happens. Okay, and then we'll switch to this one and see what's happening here. So we get demo containers. Oh, I realized that was stupid to deploy both of them because they have the same labels. Let's change that. We can do it straight here. Something like let here root no. So I'm adding root no to this one, and then I'll add root yes to this other one. But first, before let me delete these, we can do like this. Yes, and okay. And now it should be more, well, we need to also change the name. Demo no root and demo root. then maybe. It's the YAML thing you mentioned, right?
I love YAML. Oh, YAML.
All right, maybe now live demos are the best. Okay, now we can see something going on here. We are deploying in red a demo no root and a demo root. Both are coming up. Here we have a demo no root coming up, and this one has create container config error. What the hell? So what is going on there? That's in the blue namespace. Describe pod. What was the name of it? Demo root, of course. What is going on there? Error. Container has run as non-root and image will run as root. Yeah, that's what happens. And this error can be confusing sometimes because I haven't specified that the container has run as no root, but that's in the PodSecurity policy. So since I didn't specify anything explicitly in the manifest for this deployment, I didn't set a security context. The API server can mutate it to set it to something that works, so something other than root then. So it has run as non-root from the PodSecurity policy, because then it goes through. But then it tries to run as root and fails. But what we then can do to see like another kind of error is to specify this. We set the security context to run as user 0. I wonder if I can just deploy that there immediately. Blue configured. Let's see if that actually worked. No, it does not create a new one. I think I have to recreate it. And blue delete deploy. Because otherwise it's a bit tricky picking these things up since it has filled in a value there sometimes. Let's see that. No, didn't I create it? Ah, yes. I'm getting tired. This is exactly the other kind of error. We see no pod, but I created the deployment, right? So it's not a container config, what was the name? Create config error. This is another error. So what is going on here? Well, in the slides I had something that you create the deployment, Kubernetes creates a replica set, the replica set is trying to create the pod, okay? So let's see what kind of replica sets we have. RS is short for replica set. Here we have, 47 seconds ago, demo root, desired 1, current 0, ready 0. So why the hell are you not creating my pods? Describe replica set, demo root. Oh, here's another error. So you cannot create the pod, it's forbidden, unable to validate against any security PodSecurity policy. So this is like stopped before it actually tried to start the container because it wasn't able to mutate this manifest because I had hard-coded the user to 0, so it stopped already here.
Is that also exactly in the deployment status, or is it only in replica status?
Let's check what it actually says there. Deployment, because it says something like, well, you can still see this, that it has one desired and one unavailable, but you don't actually get to see like well, you can see this one failed create, but it's not like an error on that level. Yeah. This is pretty much what I wanted to show. I don't think there is more in this one. You can just marvel at the at the complexity. And
one question: you modify those the labels, but if I understood it correctly, the security policies are only applied through the service account. What was the reason you added those labels?
It was because I realized that if I deploy both the no root and the root deployment in the same namespace, well, for one, they had the same name, so they would overwrite each other. And then if I have two with different name, but the same label, the exact same label, they will sort of start a war. One scales up one, the other one sees that, hey, there is this pod with the correct label, but it's the wrong image, scale that down, create this one instead, and then they start fighting like this. So, yeah.
It's a bit surprising that it works through service accounts, so I would have expected it to be some kind of a label selector instead.
Yeah. Yeah.
What about the security context in the deployment? Like if you have a cluster and you have all PSPs set up, can you just like skip the security context altogether, since it will be added through the mutation?
Yes, I would say so. And especially, yeah, if you have if the container is completely correct, so that your container is already made in a way that it will start the process as the correct user ID, and it will, yeah, you know, all that is correct, then it will work completely without that. The only situations where I have used the security context is actually things like some containers, I think MongoDB, will run as root by default, but they can run as some other user. So as long as you specify the security context and you put in some random user, it'll work. I'm not sure that is like the right way to do it. I would rather have the right user in the container to begin with, but yeah, I don't know, it feels sloppy to have the container run as root by default, but if I override it, it still works. I don't know. Yeah, you can do those things at least. Yeah, I encourage you to play with the training material if you want to.
Did you have the repo in the slides?
I have it in the slides, yes. But as I mentioned, it's not very user friendly in a way, because this README is just basically snippets that I have used when I walk through this. But if you go into the tasks, then this makes more sense. You can sort of step through.
Can you as admin get any feedback on the violation of those policies? Or the attempts thereof?
Yeah, attempts, yeah,
yes.
Yeah.
Because if it works, then there's no
yes, you can get audit logs from the API server, so it'll log basically everything that goes through. Like this user is trying to do that, and then like a millisecond later, it has either denied or approved. So you can get those things. Yeah, that's actually also something that I would like to see by default in Kubernetes, because you get logs from the pods, right? That's quite easy. Kube control log, blah blah blah. But the API server logs, those I get they are sensitive, so not everybody should be able to get those. But actually, I think the audit logs are not enabled by default if you set up using kubeadm. They are probably enabled on all the managed services, I think, but then they ship them onto some, like in GKE, they ship onto Stackdriver, and you can look through them there. But for like bare metal, you don't have it unless you set it up explicitly. Yeah.
Did you mention that there was something that needs to be enabled in order to use PodSecurityPolicies that is not?
Yes. I can show you what. So what I did to start this cluster is this snippet here. Kind create cluster, and then I have a specific config here for network policies and PodSecurityPolicies. And what it does, it's here, kind, this one. What it does is it disables the default container network interface, CNI, because kind comes with its own very basic, so you disable that. But then for PodSecurityPolicies, you need to add this here. To the API server, you need to add this admission plugin, PodSecurityPolicy. So that's like a flag on it. I think these two are like the admission plugins that are sort of recommended. You should have them, but they are not enabled by default. The real problem, and I think the reason why they are not enabled, I'm not sure about node restriction, but PodSecurityPolicy is that for them to work, you need to have some policies there that allow the system pods to run. So, for example, in kind, they haven't created these policies, so I have to create them if it is to work. If I just enable it, things will just crash. So that's the second part here. I do this create manifests PSP, and that's basically it's a restrictive PSP and permissive. This one is the important one. So this PodSecurityPolicy, just not recommended, but this is basically allow anything, and I apply this on the system pods, so that I don't have to figure out exactly what core DNS needs and what kube proxy needs and so on. Just allow them to do whatever they want and get on with it. So the RBAC for that is this. Permissive PSP allow them to use the permissive PodSecurityPolicy, and I role bind that to the group of service accounts in the kube system namespace. So, because all the system pods are in there and created by those system service accounts.
To do this yourself, there is no like reference recommended.
This is basically taken from Kubernetes PodSecurityPolicy. There are two examples here, and I have used them straight off. What? This Zoom thing does not work. Example policies, yeah. So this is the permissive one, or privileged they call it. Allow anything, and then this one is sort of a recommended restricted one. And these are the ones I pretty much copied straight off. There is one difference. I disabled up armor, because for that to work, the node need to have up armor, and that is not available on Kind since it's running in containers. Maybe I should have started with this in the demo instead. Show how to set up the environment. But yeah, I hope it's useful. And this is of course just
the correct order. That's kind of advanced.
yeah. That's true. That's true. Yeah. So that's the permissive one. The restrictive one is what allows the other pods to run. So these are, well, you saw the policy already, but then I use a cluster role that allow specifically this restrictive policy, and I bind it to with a cluster role binding this time to all system service accounts. So anywhere in the cluster, this is fine. I think I'm a bit over time already, but thank you for listening.
Yes, thanks to Lennart and Anton for giving presentations today. You might have seen that there was some special socks here today. There's this thing where we hand out swag to people who come and speak, and then additionally you get your company and your profile up on our webpage. So we're starting to build a database of people who are active in the community and companies who are active in the community. Just then I want to thank Reaktor once more for hosting this event and showing what an office should look like. I think it's really cool. Never been here before.
Very nice. Very nice.
And I like the Christmas tree.
Yeah.
I don't have a Christmas tree in my apartment, but if I would have. Next meetup will probably be late January. We haven't, or there might be a meetup the 24th, but we haven't really scheduled anything yet. If you want to talk and get swag, reach out to me, either ping me on GitHub, my name is Lennart there, or then through the Slack channel. So you're going to go into Cloud Native Nordics, sign up with your email, you get into the Slack channel, and then ping me or Lasse or Lucas or anyone. We also have a Google form where one can go in and put in your details. And then we get pinged, but I didn't have that link here today, and I don't remember the URL. There is also that possibility. Yeah, any questions? Otherwise, thanks on my part and other organizers' part as well. Thanks for coming, and see you guys next year.
Next decade.
Yeah. That's the thing. Yes.
Has the date been set for the next
24th has been planned, but we haven't planned it that thoroughly yet, so it might change. And I think we'll start to try to do more themed events. So we have been thinking about CI/CD and GitOps. Then I would like to do something on Windows. Docker for Windows. Yeah, Docker for Windows and Kubernetes on Windows, but I don't know anyone who uses that. So that's why it would be interesting. Yeah, and then at some point we're going to do a workshop at Science Park. We have DigitalOcean has given us a shit ton of resources that we should use, but we haven't really used them in Turku yet. Yeah. Join us, go into the webpage and hook up the podcast. And then we'll continue next year. Yeah. Thanks again.
Thanks.